Hey everyone, let's look at a second example from video 10 on the kinematic equations. This example does require calculus. In this example, we are given the position of a particle as a function of time, and we want to know what is the position when it changes direction. So if you want, you can visualize it. It's not mandatory, but we do have a parabola that looks something like this, if you graph it. And we know that the position is going to go one way up here, and then it's going to go back down. So that means that at this point right here, that is when the object is changing directions. In general, whenever you change directions, that's kind of a key word that tells you that at that instant, the velocity is equal to 0. We saw this with the moving man. When he was going one way, he slowed down to a stop before going the other way. So you don't even have to picture it, but you just know when you change direction, that means your velocity at that point is 0. So with that being said, since we have the position as a function of time, we can find the velocity as a function of time by taking the derivative of that position. Once we find the velocity as a function of time, then we can figure out exactly at what time that velocity is 0. And then, once we know that time, then we can figure out the position at that time. So the first step is to find the velocity by taking the derivative. Taking a derivative of this function, we're going to get 0 for the first term, 4 for the second term, and negative 10t for the third term when we take the derivative with respect to time. So the second step we said is set this velocity equal to 0. All right, so 4 minus 10t equals 0, and solve for time. So at what time does velocity equal 0? Let's solve for time. When we solve for t here, we get 4 equals 10t, divide by 10, t equals 4 over 10. So t is equal to 0.4 seconds. And then the third step is now find x at the time 0.4 seconds. Right, so x is given as a function of time here. We can pretend this says x as a function of time, and now find x at 0.4 seconds because that will be the position at that time. And at that time is when it has velocity equal to 0. So let's go ahead and plug that in. X at 0.4 seconds is going to be equal to 3 plus 4 times 0.4 minus 5 times 0.4 squared. Plug this in to the calculator and we will get 3.8 meters. So that is the answer to this question. It required a little bit of calculus, and the main thing is to really understand that velocity is equal to 0 when it changes direction. If you do have the graph to picture this position as a function of time graph, then you know that at this point, when it changes directions, you know that the velocity at that point, right, is the slope of the line tangent to that point, which has a slope of 0. So that tells you as well that velocity must be 0 when the object changes direction.